Atmel AVR XMEGA microcontrollers are well known for ultra-low power consumption and high integration of best-in-class peripherals, like the full-speed USB and the 12-bit A to D converter. Launching the new XMEGA B family, we're adding hardware LCD controller to the list. Controlling up to 160 LCD segments and providing up to 128 kilobytes of flash memory, these devices enable easy-to-use human interfaces and ultra-low power consumption for a range of applications like mass storage and USB accessories, home automation, power tools and energy metering. The XMEGA B uses only 3 microamps in power save mode while driving a static image on the LCD with the RTC running. In addition, it sports a few quite interesting enhancements. Normally, with segmented displays, you have to handle each segment manually. Like in this example, after the initial setup, there's an inner loop per digit and another loop for every COM line of each digit. All this handling takes a lot of time, in this case more than 2600 cycles to spell Atmel. But from now on, this is old school. ASCII character mapping lets you input the ASCII character you want directly. XMEGA hardware will automatically handle the segments based on whether you have a 7, 14 or 16 segment display. Of course, this simplifies coding and requires less flash, but it also decreases LCD uptake times tremendously. The consequence is less time in active mode, meaning less power consumption. In this example, execution time and consequently power consumption was about 28 times lower using ASCII character mapping to write this string. Normally, an LCD display is refreshed at least 30 times per second to avoid flickering. And commonly, an end-of-frame interrupt from the LCD driver hardware would wake up the CPU every single time, even if you're not displaying any new info. Say you want to scroll some text across a display. Shifting digits twice per second would be a comfortable rate. Leaning on the end-of-frame interrupt for timing and handling the segments manually as in the previous example, you'd spend in the order of 30 times 2600 equals 78,000 active mode cycles per second, just to scroll some text. You could of course disable the end-of-frame interrupt and use the RTC for time base, but a more suitable built-in time base would be really nice. Enabling extended interrupt mode on the XMEGA B lets you skip up to 32 end-of-frame interrupts before waking up. Extended interrupt mode plus ASCII character mapping would handle this scrolling text task with a total of about 200 active mode cycles per second, without involving other peripherals. The XMEGA B LCD controller also has programmable segment blinking, which allows hardware-controlled blinking of all segments simultaneously or up to 8 segments individually. In sleep mode, no wake-ups. Perfect for clocks or alarms or anything where you need some type of dynamic indicator. All these features are of course implemented with the same main objectives in mind: to have an LCD controller as self-sufficient as possible for less CPU active time and less power consumption. Finally, let's look at swap mode. Designing a PCB with more than 40 signal lines from your micro to a segmented LCD display, you're facing many limitations on your hardware design. Swap mode enables internal rerouting of the segment lines. You get much more flexibility with component placement and can avoid complex signal routing with lots of vias and so on. Besides LCD enhancements, the full-speed USB module with an industry-leading throughput and low CPU load ensures easy firmware upgrades and connectivity. Running full-speed USB off the internal oscillator takes external components off your bill of material and gives back valuable design time. Of course, you also get the high integration and system performance that defines the AVR XMEGA family. DMA, event system, ultra-low power consumption, high-precision analog. Also, the 100-pin members of the new XMEGA family have dual 12-bit ADCs, allowing synchronous sampling, which is perfect for electrical metering, where you have to measure current and voltage simultaneously to get accurate power measurements. The new XMEGA B devices are fully supported in AVR Studio 5, with drivers for everything, including the LCD controller and the USB module, of course. For hardware evaluation, we provide the AVR XMEGA B1 Explain Kit and the AVR STK600 LCD 160 extension board for the STK600. These supported the XMEGA B1 and B3 devices. So that's it, and thanks for watching.